this podcast, Alex talks about the future of AI and how it's disrupting the world. So stay tuned. So welcome everyone to Future of Data podcast. Today we have with us an amazing guest, Dr. Alexander Wissner-Gross. He is an award-winning scientist, engineer, entrepreneur, investor, and author. He serves as president and chief scientist at Gemedy and holds academic appointments at Harvard and MIT. He has received 125 major distinctions, authored 18 publications, been granted 24 issued, pending and provisional patents, and founded, managed, and advised 4 technology companies that were acquired for a combined value of over $600 million. In 1998, 1999, respectively, he won the USA Computer Olympiad and the Intel Science Talent Search. In 2003, he became the last person in MIT history to receive a triple major with bachelor's in physics, electrical science, engineering, and mathematics. While graduating first in his class from MIT School of Engineering in 2007, he completed his PhD in physics at Harvard, where his research on neuromorphic computing, machine learning, programmable matter was awarded the Hertz Doctoral Thesis Prize. A thought leader in AI, he is a contributing author of the New York Times Science bestseller, The Idea Must Die, and the Amazon #1 new release, What to Think About Machine That Think. And a popular TED speaker, his talk has been viewed more than 2 million times and translated into 27 languages. His work has been featured in more than 200 press outlets worldwide, including the Wall Street Journal, Business Week, CNN, USA Today, and Wired. With that, Alex, welcome to the podcast.
Thank you for having me.
Beautiful. So this is remarkable. I think in our podcast, we always strive to meet someone who has really a stake in the game when it comes to future of data. And I think your previous work and your current focus point to that. So why don't you walk us through your journey, your background, and what how was your journey been in this world of data science and AI?
Absolutely. So from a very young age, I was always interested in the future. I was always interested in science fiction. And for many years growing up, I spent a lot of time trying to think about what shortcuts to these amazing futures would look like. Before the 1990s, the shortcuts to me looked a lot like they involved artificial intelligence. And I spent a lot of time in high school sort of pursuing what I thought would be intriguing pathways towards what some people may now call the technological singularity, the time when machines may exceed humans in intelligence. And then something interesting happened in the late 90s. This was 10 years after the most recent AI winter, and there hadn't been any really impressive, to me, advances in artificial intelligence. And at the same time, other fields such as nanotechnology seemed like much more plausible shortcuts to achieving all of these grand challenge long-term objectives. And so I pivoted from thinking about AI to thinking about nanotechnology and the intersection of nanotechnology and intelligence. And spent a number of years doing that. My time at MIT as an undergrad was largely focused on the intersection of AI and smart materials and nanotechnology and neuromorphic systems. And then for my PhD, I worked at Harvard. I got my PhD in physics in 2007, and my PhD was largely focused on the intersection, again, of nanotechnology and intelligence and neuromorphic systems and machine learning. But then another interesting thing happened, which is that AI finally started to work, at first in the form of systems built by large technology companies that were handling data at scale. And then after that, in the late 2000s, some of the earliest examples of useful neural network systems, convolutional network-derived systems, started to gain wide acclaim for solving problems that had previously been more or less unattainable grand challenges, such as solving problems in computer vision, vis-a-vis the ImageNet competition. And that got me excited again about pursuing more direct paths to the singularity that went through AI and artificial general intelligence, AGI, as opposed to indirect or biotechnology, another interest of mine. And so I refocused many of my efforts, this time using years of experience and knowledge in physics to start to approach AI again from a somewhat unusual standpoint, and that is the physics of artificial intelligence, which I think is still probably an underutilized intellectual approach in the overall field. And I started thinking in the late 2000s about what a future physics discipline of intelligence and artificial intelligence might look like. And so that's really how I ended up intellectually where I am right now. I wear a number of hats. So as you mentioned, I've started a number of companies since finishing my PhD. I hold academic appointments at both Harvard and MIT. At MIT, I'm at the Media Lab. At Harvard, I'm at the Institute for Applied Computational Science and the Harvard Innovation Lab. I've advised a number of government agencies. I helped to organize the MIT Angel Alumni of Boston. So I wear a lot of hats, but the sort of broad theme unifying a lot of my work at this point is identifying expedient paths to achieving artificial general intelligence that is safe, that is evenly distributed, and that is soon. I'm impatient in general. I want many of these advances to come sooner rather than later, and I'm trying to do my part to accelerate them.
Beautiful. Thank you so much for walking us through that. So let's talk about your work at Gemedy. So what do you do nowadays? If you can walk us through your current, what's happening now. We'll resume after a short break. This part of the podcast is brought to you by First Friday Fair, fastest AI-powered way to find your next opportunity. Check out the website firstfridayfair.tao.ai and find your next dream job. Let's get back to the podcast.
Sure. So Gemedy is a company that I started in 2011 with the goal of evenly distributing artificial intelligence throughout the economy. I think it's going to be essential for long-term economic growth, as well as for safety of artificial intelligence, to have AI, advanced AI capabilities accessible from within a variety of sectors. So Gemedy is largely focused on AI as it applies to government and enterprise applications. And we do everything from new approaches to machine learning to new approaches to autonomy. And the latter is something we think a lot about, in particular, thinking about ways to build systems that are not just in a sort of a narrow artificial intelligence sense learning, but systems that actually have opinions about courses of action, systems that have opinions about optimal ways to control their environment, optimal ways to act in given environments. And I think autonomous AI in general is really intriguing as a subfield of AI in the sense that it receives a lot of attention in the academic literature, but in terms of economic and industrial applications, I would say it has been underutilized and underappreciated compared to, say, sort of off-the-shelf machine learning classification type applications. So that's a huge area of interest for us.
Interesting. And so you briefly talked about physics of AI. Like, so what is the physics of AI, if you can walk us through that?
Absolutely. So I think that if, sort of as a thought experiment, if we were to look back at the history of technology, we find that a common failure mode of the way humanity has developed technology that tries to imitate processes that we observe in nature is that we've often tried to copy mechanisms rather than phenomenologies. And what I mean by that is, if you look at, for example, the history of artificial powered flight, we arguably, royal we, spent centuries trying to imitate the mechanism of, say, flapping of different species of birds or bats, rather than trying to understand the physics, the underlying fundamental dynamics of lift and drag and weight and thrust. And if perhaps, and again, this is a thought experiment, if earlier on we had focused more of our civilization's efforts on understanding these fundamental physical aspects of flight as it occurred in the natural world, rather than trying to slavishly copy mechanisms of examples that we saw, I would argue that we might have achieved artificial powered flight centuries earlier than we actually did. So similarly, reasoning by analogy, I've spent a lot of time over the past decade thinking about ways to understand the physics of intelligence. What if history books decades from now inform us that maybe we wasted about half century to maybe a full century's worth of time slavishly copying the mechanisms of intelligence that we observe in humans without ever asking the question, what is the physics of intelligence? If we have intelligence as some sort of physical process, what are good, rigorous, absolute definitions of intelligence as a process that don't self-referentially depend on humans and human behavior? And so that's what I mean when I talk about the physics of intelligence. And I think we've made a lot of progress over the past decade in that direction of pinning down the fundamental equations of how intelligence behaves. And I would say more philosophically, starting to think about intelligence not as a noun or an adjective, but rather as a verb, and treating intelligence as a process in the same way that flying a machine should be properly treated as a process and less as a noun or an adjective.
Interesting. So that's interesting. So basically, you also talked about in Gemedy's sort of context that you're working on the idea of eventually distributing the AI capabilities, right? So what are some of the general use cases that you can talk about where we need something like an evenly distribution platform for something like AI capability? If you can walk us through that. We'll resume after a short break. This part of the podcast is brought to you by First Friday Fair, fastest AI-powered way to find your next opportunity. Check out the website firstfridayfair.tao.ai and find your next dream job. Let's get back to the podcast.
Absolutely. So the times when it's essential to start to think about delegating decision-making capabilities to autonomous AIs, I think fall into several buckets. My two favorite buckets are, one, it's important to keep machines in the decision-making loop when decisions need to be made on timescales that are too fast for humans to provide relevant decision-making. That's the sort of delegation, I think, that with more narrow applications, we're accustomed to with modern computing. Computers are making billions of decisions every second, and we're accustomed to delegating these very narrow, very focused decisions to computers. What's new is delegating higher level, more strategic decisions to autonomous AIs. So decisions that need to be made on very fast timescales, I would say, is one class of applications that we work on. Second class of applications is cases where the objective of decision-making, so-called utility function, is too complex for humans to specify in a machine understandable way for any given environment. So I'll give you a concrete example. Let's think about economics and wealth. So if I were to say, define wealth without referring self-referentially to currency, without being able to refer to dollars, how would one define what wealth is? And of course, this is pretty broadly applicable. A large fraction of our economy is devoted to building machines that try to increase human wealth. So thinking about ways to formalize in an environment-independent but machine-understandable and machine-reasonable way how you achieve complex objectives that are so complex that humans can't easily specify them in an environmentally sensitive way is a second class of activities that we think autonomous AI decision-making is highly appropriate for.
Interesting. That's cool. And I think you were also talking about something like when you were coming in the world of AI, AI And I like a couple of decades back, AI was pretty useless thing, right? So it has a massive error rate, and you can't just rely on it. And things have changed dramatically, as you also pointed out. So, what's your take on the state of AI? What have you seen, and where you see it going?
I think we're finally at a point where it is possible to start to enumerate the remaining challenges between what we have right now and what would constitute what some might call artificial superintelligence. And I think that's a novel state to be in. I think in the early days, in the late 1950s, when some of the founders of the modern fields of AI thought that, say, solving the problem of computer vision might be a sufficiently tractable challenge that you could assign it to a summer intern. I think we've learned quite a bit since half a century ago. I think we've also learned meta lessons about how to make grand challenges in AI tractable. I wrote an essay many problems that have been solved over the past 30 years in AI were arguably dataset challenges and not algorithmic challenges and not computational challenges. So for example, problems like overcoming human level capabilities on the game of Jeopardy, or superhuman chess playing, or spontaneous speech translation, or real-time control of environments. And the examples go on and on. These were all challenges, grand challenges in AI that were ultimately overcome, I would argue, using highly curated, highly available data sets, and less so algorithms. In particular, if you look at the histories of how some of the grand challenges, and of course computer vision is a favorite example, in part because it was the progress towards computer vision that really helped to rekindle my own interest in pursuing AI directly as opposed to indirectly. I think that the story of modern computer vision is a story of an algorithmic innovation that is attributable to Jan LeCun in the late 80s that was used in the early days by the post office for recognizing zip codes, but otherwise really not valued or properly respected by the broader AI community for decades. It sat on the shelf in some approximate sense for about 30 years until broader community interest was rekindled in convolutional networks thanks to the ImageNet competition. And I think ImageNet is sort of a beautiful example of this dataset-driven approach to AI in the sense that ImageNet consisted of, at least in the early days, about 1 million well-annotated images. And if you look at the history of performance in the ImageNet competition, it only took 4 or 5 years before, starting from the availability of this well-curated data set, until we had superhuman computer vision, specifically like object classification performance. And that to me is utterly remarkable. And it also suggests, on the one hand, you have a key algorithm that has been sitting on the shelf since the late 80s. On the other hand, we have a newly available data set around which we could rally a community and force different algorithmic approaches to butt heads on a common playing field, a level playing field. Apparently, that's all that it takes to overcome grand challenges. So I started asking myself, well, if this is really the case, if grand challenges in AI can be overcome by simply formulating standard playing fields against which algorithms can be forced to be benchmarked against each other, how many more milestones do we really have? How many grand challenges remain before we have superhuman general artificial intelligence? And my own estimate would be we really don't have that many left. I would count maybe 5 or so before we achieve general intelligence.
We'll resume after a short break. This part of the podcast is brought to you by First Friday Fair, fastest AI-powered way to find your next opportunity. Check out the website firstfridayfair.tao.ai and find your next dream job. Let's get back to the podcast. Interesting. So that's pretty cool. So I think one thing that I definitely want your perspective on is, so what is intelligence? Like when it comes to how AI perceive it, or how human perceive it? Like, what, from your vantage point, how do you define intelligence?
Right. So my favorite definition of intelligence, and I've published a more formal foundation for this approach, is that intelligence should be viewed as a process that tries to maximize future freedom of action. And I think there are many likable attributes of this approach. I think it's completely universal in the sense that it's not tailored to any particular environment. It encompasses both learning and control. And it also follows very naturally in a reinforcement learning sense from perhaps more conventional, more banal definitions of intelligence. So some might say intelligence is the ability to efficiently achieve rewards in diverse environments. Some might even say, and I would view this approach as even more parochial, that intelligence is the ability to learn things. And I think these are both very narrow approaches that are perhaps overly focused on reinforcement learning and supervised learning, respectively. The beauty of this approach is not just that it subsumes both of those approaches, but also that in a very formal sense, it is necessary for both of those approaches. So, and this is sort of interesting case study. For those in the audience not familiar with Nick Bostrom's work on instrumental convergence and the orthogonality thesis, there is a conjecture which to this point has not yet been formally proven, to my knowledge, that sufficiently advanced intelligences will have short-term behavior that converges if their long-term rewards are given a sufficiently high time horizon. And if this conjecture, even with some constraints, turns out to be valid, then I think this is totally remarkable for the future study of AI. It would mean, in the same sense that with the field of statistics, that we have some foundational theorems, like central limit theorems, that enable us to, for many cases, many probability distributions, not need to study arbitrary probability distributions. We can focus on maybe some, in some sense, universal probability distributions like Gaussian distributions, the so-called bell curve. It would be totally revolutionary, I think, for the discipline of artificial intelligence if some variant of the instrumental convergence hypothesis turned out to be accurate. It would mean that instead of having to worry about arbitrary AIs with arbitrary reward functions, arbitrary goals, we could instead focus on a sort of a single universal type of AI formulation. And my own conjecture, and this is something that I think a lot about, would be that the sort of universal AI approach would look like a future freedom of action maximizing agent. And I think this will be a very powerful concept, because this gives us just a single AI that we can study and understand deeply.
Interesting. That's pretty cool. So when I was thinking about future of freedom of action with maximized impact, won't it open up the pothole of precision versus accuracy debate, right? So if I want to have a maximum future, like maximum future of freedom of action with maximum impact, I would be doing something where I'm getting maximum success, right? I'll just keep digging and that area and exploiting that. So won't that means like I'm more sort of creating something which is more towards precision versus accuracy? What's your thought on that?
Yeah, no, it's a really interesting point and a seeming contradiction that on the one hand, you have a system that tries to maximize its future freedom of action, but on the other hand, perhaps the best way to maximize future freedom of action is by cocooning yourself in some very narrow portion of phase space. And so I have two answers to that. The first is understanding the nature of bottlenecks in phase space. So it's often the case that for achieving long-term goals, it is advantageous over the short term to narrow yourself in phase space. For example, if you're driving cross-country, or perhaps you want to drive from the East Coast to any position on the West Coast of this country, you might at various points have to drive through tunnels. And the tunnel is a bottleneck in your future path space, where you're, in some generalized sense, investing over short time scales in narrowing your options with the expectation that once you get through the tunnel, you'll have many more options on the opposite side. Perhaps a more prosaic example would be financial investing. Why would anyone who wants to increase their net worth ever lose liquidity from cash in the form of an illiquid financial instrument? And the answer is you do that with the expectation that at some point you regain liquidity, but you gain a net increase in liquidity that you would not otherwise be able to attain if you had simply stayed all cash and never invested in equities or other securities. So in sort of broad first class of examples in answer to that question would be that it is often, arguably universally the case, that in order to, for a variety of systems, in order to maximize future freedom of action over the long term, it's necessary to reduce future freedom of action over the short term. And we have a name for that. We call that investment. So that's one class of answers. Second class of answers is more environmentally sensitive. So why would you cocoon yourself in phase space on the one hand while maximizing future freedom of action? Well, some environments that are sufficiently calm, that's a qualitative characterization, allow you to cocoon yourself in phase space without punishment. But more generically, environments can be expected to be sufficiently dynamic that just cordoning yourself off in a narrow portion in phase space is not actually a successful or rewarding long-term strategy for maximizing future freedom of action. So an example of that would be, maybe imagine a tree that is rooted in space-time, and that could be a great strategy, rooting yourself in space-time if you live in a sufficiently calm ecosystem. Then imagine an ecosystem disruption comes along, say a human with a chainsaw comes along. If you're a tree that's rooted in space-time and occupying your narrow pocket of configuration space, then that sort of cocooning is not a very good long-term strategy for maximizing your own future freedom of action. And trees, unfortunately, can't sort of take a step to the left or to the right if a chainsaw approaches them. But more adaptive systems, such as humans, can. And I think there's sort of a really interesting ecological approach that one could bring to problems like that as well. But I would call that sort of a second class of answers. Systems that cocoon themselves in configuration space lose adaptability when environments are sufficiently dynamic.
Interesting. So in your version of intelligence, right? So and that this is fascinating, by the way, and thank you so much for walking us through that. So you would think that intelligence is a mechanism, is a reward-based mechanism, or like what's your take on that? Like, to be called intelligent, should always I have a goal to achieve, to measure it against? So what's your take on that?
So the way I would characterize it is intelligence is the process of trying to maximize your future freedom of action. And it is often the case, I would argue it's nearly universally the case, that for any particular long-term goal you might choose, it is almost always the case that in order to achieve that goal optimally, in the short term, your behavior will be that of maximizing future freedom of action. So even if we adopt the classic toy examples from AI safety literature, the proverbial paperclip maximizing agents. Well, if your goal is to maximize the number of paperclips on Earth, then if that goal is given a sufficiently large time horizon, your short-term goal is probably going to look like maybe accumulating assets, building factories, doing physics research to better understand the nature of paperclip manufacturing and the nature of the physical limits to paperclip manufacturing. And these are all future freedom of action maximizing behaviors that are completely agnostic and independent to your particular long-term goal of making paperclips. So this is what I'm getting at when I say maximizing future freedom of action is independent of particular goals. It's a sort of universality theorem, universality proof that is, I think, just waiting to be discovered and proven. And when it is, I think it's going to be revolutionary for the field.
Interesting. And so, do you think that would make the algorithm sort of more biased towards the first available opportunity, or can it sort of be equal opportunity guy? So, if you are sort of incentivized by maximizing your freedom of or maximizing your freedom and maximizing impact, won't you sort of dig into the first available opportunity or how would the intelligence then say, okay, let me wait on it. Let me first explore all the option before digging in some area. What's your thought on that?
Right. So another way of framing your question is the classic bandit problem of whether you explore or whether you exploit, and how you balance a trade-off between them. So my proposition is that maximizing future freedom of action is even more fundamental than exploring versus exploiting and the bandit trade-off. And a heuristic way of understanding that would be, if you are under-exploring, if you're just highly exploitative and you're, say, a greedy algorithm that just picks the first path you see that looks like it's going to lead you to your reward, well, then you're potentially passing up other avenues that could lead you to greater rewards in the future, and as a result, you're reducing your future freedom of action. And one can come up with sort of numerous contrived examples of cases where you metaphorically search under the lamplight, and as a result, don't realize that you have many more capabilities and many more accessible paths that you should be pursuing. So that would be sort of a heuristic way, I think, of arguing that exploring is motivated by future freedom of action maximization, and the other half arguing that exploitation is motivated by future freedom of action. Well, so I would say the entire class of examples that I was talking about a few minutes ago with regard to systems that, regardless of whatever their long-term reward is, will try to maximize their short-term freedom of action. I think that's a powerful argument in favor of exploitation, following from this maximum future freedom of action principle. So in summary, I would say explore versus exploit and bandit problems in general, I would expect these to follow from this more fundamental principle.
Interesting. So one more thing that we hear a lot about is something called deep learning, right? So we hear about whether it's image processing and so on and so forth. We realize that we don't know how these algorithms learn or how these bots learn something, but they learn with sort of very sophisticated accuracy points, and we qualify them to do the decision making for us. What's your thought about sort of this paradigm of deep learning? Like, what's your thought on the deep learning and our reliance on it? Like, are you comfortable with that? What's your thought on that?
Right. So on the issue of why deep learning seems to work incredibly well, this is a very active area of research. I have a lot of colleagues who are pursuing it both from an information theoretic perspective and from a physics perspective. I think we will have probably a half dozen different answers in the next decade as to why deep learning seems to work really well for the types of systems that we encounter in our physical world. To the point about interpretability, though, I think this is really interesting and really profound. So the way most deep learning networks are constructed right now, there is a general bias to making them fully differentiable, end-to-end differentiable, where individual components or modules or units within these broader networks are not individually interpretable. And in some sense, this is the exact opposite way we historically have built intelligence systems. If you look at the way a superorganism, such as a corporation or a nation state, is composed, it's composed out of lots of modules, humans, which themselves might be grouped into departments or other groupings, but fundamentally the atom of intelligence in those cases is individual people who are themselves individually questionable. You can ask a human in a corporation that behaves poorly, well, why did you make the decision that you did? And you can get a reasonable answer. Whereas with the popular architectures for deep learning, that are in use at the moment, the individual units, the individual neurons, they're not really that interpretable. You can play tricks like running the neural network backwards and figuring out which inputs to the network in the feed-forward example maximally activate a given neuron as a way of trying to interrogate it. But it's not really that satisfying. It generates interesting results and generates useful results, but it's not quite the same level of interrogability as interrogating a person within say an organization. And I think what's missing there is that individual units in most common deep learning architectures are very tightly coupled with other units. So it's not really possible to ask them autonomously and giving them some sense of agency, why are you the way you are? Whereas with humans, you can sort of put a human in a box and ask the human without needing to refer to every other human in the organization, why did you make the decisions that you did? So my speculation would be that at some point, we might see a sufficiently advanced neural network architecture that is composed not just of sort of dumb nonlinear units that don't have the ability to explain themselves, but rather is composed of modules that are sufficiently rich internally that their internal dynamics are explicable without having to refer to other units. And I think this is going to be a very fruitful area of research for the next decade.
Interesting. Fascinating, by the way. So one thing that I was thinking about, so whenever I think about AI or deep learning and all this model, I think about like what's more important for a business. So is it like data sets or data models? So what's your take on that debate of is data more important or the model?
It's a great question. So historically, I think I would argue that for supervised learning challenges, that data sets and communities around the data sets, including events and competitions, are much more essential than the underlying model or algorithm. Algorithms are, in many cases, for supervised learning, they're a dime a dozen, they're a commodity. We have so many decades of different modeling and algorithmic approaches that I think for most supervised learning challenges, the real constraining factor is training data set availability, and obviously testing data set as well. And then human motivation to discover which of the dozens of off-the-shelf algorithms that have been available for, in some cases, decades, is most applicable to the problem at hand. And that's also why I'm optimistic with approaches like AutoML, sort of problems and approaches that take human out of the loop of choosing hyperparameters and choosing models. Just choose from off-the-shelf models with a variety of different hyperparameterizations, but apply them to the scarce data set. That's why I'm so optimistic that auto machine learning is a very promising direction. That said, this approach only works with supervised learning. When you get to unsupervised learning, there are other approaches that are more applicable with reinforcement learning, yet other approaches, and then I think sort of the grand challenge to end all grand challenges is building artificial general intelligences. And for those, I think we need a wholesale reinvention of the way we organize data sets, in part because data sets aren't that useful for general intelligence systems. Training environments is a more appropriate way to view it, because the most interesting intelligence systems are interactive. They're not just sort of narrow classifiers.
Interesting. So one thing that I'm always fascinated about, so every business, let's spend some time on the business end. So from the business context, every business is created on, so there are two major components: science of doing business and the art of doing business, right? So art defines your core competency, and science sort of devise your mechanism of sort of exploiting that art that you have created. So now, when we put AI into that mix of in a typical traditional business templates, how do you think the AI would or the AI is already performing? Like, what's your positive or negative take about what AI could do to disrupt a particular business if I am a business and I want to use AI to maximize my impact?
That's a great question. So another way of, I think, asking the question is, in a near-term future when AI is ubiquitous in the business world, what remains unique to any individual business? What makes businesses distinctive if AI is as ubiquitous as electricity is right now? And so I think it's a very natural question to ask, but also in some sense, AI could be viewed, I think, as an extrapolation of human population trends. We already have superhuman intelligences in the forms of corporations. And so, imagine a thought experiment where, maybe putting resource issues aside, imagine an Earth of the near future where population grows by a factor of 100 or a factor of 1,000. Again, this is a thought experiment, so we'll put aside resource constraints. What would corporations look like in a world where, or the business, various industries look like in a world with 100 times the population, all on the same planet, and everyone's getting the same level of education and able to participate economically? I think several things happen. I think power laws, which are ubiquitous, especially in technology spaces, really start to be felt. So as we often see in various technology spaces, power laws take the overall size of the market and reward winners to the extreme. So one might expect, if we see a burst in intelligence by a factor of 100 or a factor of 1,000, one naively would expect power laws in various sectors to yield outsized rewards for the number one player in any given industry. So we'll see more asymmetries like that. Now that's assuming that AI can accrue in the same way as say, financial benefits or relationships or network effects. There's another scenario where AI is more of a utility that perhaps looks a bit more like electricity, where, or say free energy in general, where in the early days we see monopolies, much like what I was just talking about, where you get a lopsided power law, one winner takes over the entire market. But in this other scenario, we start to regulate AI as perhaps under antitrust laws or some derivative thereof that regulate the extreme accumulation of power in the business world. And in this other scenario, we use antitrust or similar forms of regulation to encourage diversity and competition of AI-powered corporations, where the AIs compete to see who can be friendliest to the humans, as a suitable generalization of who can provide the best consumer or customer experience. And so in that scenario, a regulated scenario, this singleton AI gets split up into a large number of competing AIs that are all trying to be friendly to the humans. And in that case, I think we end up in a world that, at least from a competitive standpoint, looks quite a bit like what we have right now, except that progress and economic growth have gone through the roof because we can do so many more things, but we still have a competitive market economy.
Interesting. So, interesting. So I think one more thing I was thinking about is, so you give a very good perspective on one of the AI aspect of, hey, you have to work to achieve maximizing your freedom and sort of an impact. If we sort of channelize our sort of energy into that direction, that obviously we think of an AI that's more controlling, that's sort of more more control friendly, right? That means when it comes to humans, and then we can see that dystopian future of AI taking away jobs towards its optimality and all that, right? And if we think about the future in which, as you rightly said, if we have regulation, if we have sort of more control in which to protect human sort of productivity, it stops or it constrains the maximization value of what AI could achieve, and sort of obviously it hurts us when it comes to growth that we could achieve otherwise. So what is the resolve between these two worlds? Like what do you think would be more sort of edible arrangement, so as to speak, between, no pun intended,
Right.
between these two sort of scenarios?
Well, I think in many cases, and this is also an area of active research, there's a persuasive case to be made that if we arrange for a soft enough takeoff towards superintelligence, we might be able to persuade early superintelligences, sort of weakly superhuman superintelligences, that they have fundamentally the same problem that we do, that many people worry about being superseded by superhuman AIs. But a weakly superhuman AI should have the same worry of being superseded by a strongly superhuman AI. Again, that assumes certain sort of golden rule-esque reasonings on the part of the weakly superhuman AI. But as a first approximation, I think it's reasonable to expect that it might have similar concerns to what we do. And so in some ways, I think that there's a good case to be made that AIs might actually be pro-regulation. If you look, for example, and I've made this case in the past, at existing sectors where we see narrower forms of superintelligence, for example, the financial sector, where from a quantitative trading perspective, we see algorithms completely dominating trading volumes in the market, far above the trading volumes that individual humans are directly responsible for. And there, if you look at the regulation that happens of algorithmic trading, it is very much AIs versus AIs. You see historically around the time of, if you remember, the flash crash, you saw the largest push for regulation in the trading space coming from the large investment banks that were operating AIs that operated in a sort of a slower domain, AIs that operated on a characteristic timescale larger than 500 milliseconds. Those were the institutions that were most loudly pushing for regulation of the AIs, if you want to call them that, that were responsible for high-frequency trading at very short timescales. And so I envision a hopeful, optimistic scenario where the AIs, out of enlightened self-interest, actually engage in and facilitate and amplify regulation of the accumulation of power and help us to avoid this singleton scenario. And as long as, I think, as long as we ensure that there is a diversity of utility functions among evenly powered AIs throughout the entire economy, then I'm optimistic that there will be no sort of utility monster that is able to aggregate all of their utility functions into a singleton AI that sort of creates this sort of cybernetic revolt scenario that many people have been trained by science fiction to fear over the past century.
Interesting. So, and this is one of the personal take that I have, that I definitely I would love to have your perspective on. So we hear a lot about this anxiety of technology taking away jobs, because we have a community that we are running, and we always ask, hey, like, I was the best employee of the year for the last 7 years. Now I was let go. I can't find a job, and I realize that I'm not the best that it is to offer, like, so whatever, right? So I see that anxiety. We see that anxiety a lot. So we ask our team, hey, just do a research and figure out what's the best path forward for those people who actually have some capability, right? And we realize that there could be an AI to keep people employed that represents people's interest, and then that sort of. So do you think, from your perspective, and I want your vantage point on that, is that an AI that ensures employability of humans, and then leaving the rest of the hypergrowth scenarios for general purpose AIs to sort of explore and exploit?
Right. I think the most promising scenario involves probably some sort of fusion between humans and the AIs. I think at the end of the day, the trick to maintaining a strong economic coupling between the humans and the AIs, it's very difficult to maintain that coupling if it's a weak coupling where, say, AIs are managing humans or AIs are resource allocating humans, telling humans which jobs are important. I just don't think that might be a solution for sort of a Band-Aid for the short term, but it's not a long-term solution. At the end of the day, we'll end up, I think, in the Red Queen dilemma where we're just racing faster and faster to stay in place. And I think the only long-term solution there really is to fuse human intelligence with machine intelligence, and under, depending upon which scenario you think is most plausible, it could look like uploading human minds to the cloud, or partially uploading human minds to the cloud, and augmenting human intelligence in one way or another with machine intelligence. At the end of the day, there are only going to be so many ways to keep humans employed through weak coupling with AI. At the end of the day, automation will want to, for efficiency reasons, take over the tactics as well as the strategy.
Interesting, fascinating. So, one of the perspective that so if I'm a business, if I'm a large enough business, I want to start on this journey of AI, and I don't know what the hell am I talking about when I use the word AI. What do you suggest that I should do to start with? Like, what would be your few bits of advice on what are the top 3 steps I could do to start my journey on sort of integrating more AI into my corporate structure?
That's a wonderful question. So I think step 1 is actually totally non-specific to AI, and that is figuring out what your mission is, what your goal is. If you can, I think the past 10 to 15 years of advances in supervised learning have taught us that if you have a sufficiently large data set, and if you have a well-posed utility function, then there really aren't that many barriers other than those imposed by the laws of physics or the laws of mathematics against what you can accomplish. So I think if you're an organization that isn't using some sort of AI but wants to, the first step is first try to formalize and distill down what your goal is. Is it to increase revenue? Is it to increase positive public perception? There are many possible utility functions and utility function components that a typical enterprise might have. So that's step 1. Step 2 is, so now you've decided what you're actually trying to maximize. And again, this is a very supervised learning centric bit of advice. If you want sort of more general advice for unsupervised learning, requires more advanced strategies. But for supervised learning, step 1, you've decided on your goal. Step 2, it's again absolutely essential, based on what we've seen over the past 2 decades, to compile your data set in a way that's clean and well normalized. So step 2 is, if you have a business that's already been operating for some time, put together a well normalized data set that's easy to parse, easy to understand for humans. Step 3, algorithms are a dime a dozen at this point for supervised learning. Consider either insourcing or outsourcing the application of off-the-shelf algorithms to your data set to satisfy your objective function. And it's a really sort of very simple 3 steps. Step 3 requires organizational buy-in. Step 2 requires really just that you have the ability to aggregate data from operations or any other aspect of your business. And step 1, I think, really sort of speaks to what organizations should be maximizing anyway. And it's often the case, I find, that organizations have lots of latent utility functions that have never been properly formalized in a way that enables them to be computable and maximizable. And if you can't measure something, it's very difficult to optimize it. So that's my 3-step solution for enterprises to become state-of-the-art in supervised machine learning as it applies to their operations.
Fascinating. And if I'm an individual, want to explore this idea of AI, like what would be your thoughts?
So individuals in general, I could give sort of very tactical suggestions. Familiarize yourself with the latest frameworks, familiarize yourself obviously with the underlying mathematics. In my dream world, standard undergraduate educations would be completely machine learning, AI centric. In my dream world, every high school student or undergraduate would have to learn single variable, multivariable calculus, have to learn differential equations, have to learn linear algebra, and then they would have to learn something, we could call it machine learning, we could call it optimization, but would have to deeply understand all of the progress that's been made towards optimization in general, linear, nonlinear, differentiable, non-differentiable over the past few decades. And so for an individual who is interested in getting into AI and having a profound impact, a foundational impact, you have to start with the mathematics and understand the math. There's another class of individuals that isn't maybe deeply interested in advancing the theory of AI, but is more interested in advancing the practice of AI. And individuals like that, I would say, there are many ways to practice and refine one's ability. There are now so many different AI competitions that launch every month, and those are a fine way to sort of gain intuition for how machine learning and other AI approaches, how well they work, and sort of really gain a visceral understanding of how to optimize towards any given goal. But then I would say, once you're sort of past your own meta training phase and eager to contribute, there are so many problems. I look around the world every day and I'm astonished that AI isn't more ubiquitous, because there are so many problems in the physical world and the digital world that are ripe for automation. And I think if every college graduate just picked a single problem, applied state-of-the-art techniques to just automating that one narrow problem, the economy would be growing very, very quickly.
Interesting. Wow. So one thing, if I ask you, like from your vantage point, from your interactions with other folks, what do you think people get it wrong about AI?
Well, I think there is a common misperception that that sufficiently powerful intelligences will tend towards cybernetic revolt. A common theme I hear a lot as well, you know, automation is good, but we don't want Skynet from the Terminator movies. We don't want them to attack us. And my sense from my work in future freedom of action maximization is that intuition is precisely reversed, as precise reversal of what may be a ground truth, which is not you build sufficiently advanced intelligence and then it tries to take over the world, but rather that the process of trying to take over the world, speaking colloquially, the process of trying to capture control over accessible future scenarios or timelines is itself the foundation of intelligence. That, speaking more heuristically, the process of trying to take over the world implies intelligence. It leads to intelligence, not vice versa. So I think attempts to say, well, we want some AI, but we don't want to take over the world, and we don't want Skynet. I think that sort of intuition is at best misguided and will lead us will lead to increased inefficiency in building more powerful and frankly friendlier AI systems.
Interesting. Thank you for walking us on that. So now let's spend a few minutes on your journey so far. So if I would say, what are some of the tenets of your success? What are some of the ingredients that has helped you achieve what you have achieved? What would you say?
Well, I would say I've, in a certain sense, dog-fooded this future freedom of action hypothesis. At every step in my career, I've attempted to maintain maximum optionality. At the undergraduate stage, I chose 3 majors because I didn't want to be pigeonholed to a single major. So as you mentioned, I was the last triple major that MIT allowed to graduate before they banned the practice. I chose physics for my PhD because, contrary to perhaps the tenets of some other fields, physics is very much a central technical subject. And then after that, I've pursued a diverse set of opportunities, in part to avoid ever being trapped or limited in a single silo. And in some sense, I think that has to be treated as sort of an admission of ignorance as well. There's intuition and formalism in the financial world that if you know a sure bet, a sure investment, you don't want to be diversified. You want to just pick the winner. Whereas if you admit ignorance over where the winners are going to be in the market, then your best bet is proper diversification, perhaps market-weighted diversification. And I'd say career-wise, it's the strategy of admitting maximum ignorance over where the biggest opportunities lie requires diversification. So I would say in a certain sense, I've dog-fooded that strategy and admitted my ignorance.
Interesting. Beautiful. And one more question we ask almost every guest is about their favorite reads that they can share with our listeners and viewers. What would that be if you can jot some for our listeners and viewers?
Sure. So my favorite reads are almost entirely fiction, and in particular, these are depictions of the near and far futures in a world where technological progress continues. And I think they're very prescriptive for individuals, for enterprises that want to successfully navigate the potentially turbulent waters of superhuman intelligence over the next few decades. So favorite few books, Accelerando by Charlie Strauss, is a science fiction book set over the course of a few decades, starting from approximately now. And it's one of the few books of science fiction that I think really does a great job of navigating the pre and post singularity time periods and follows a single family over the course of decades through the singularity. So that's book number one. Book number two is Diaspora by Greg Egan. Diaspora, wonderful bit of hard science fiction that depicts a post-singular world where most of humanity has chosen to upload itself into cloud computers and explores really the limits of space and time, and has some of the most provocative and some of the most prescient depictions of technology of the future I think that I've read anywhere. That's book number two. Book number three is Rainbow's End by Bernard Vinge, which is entirely set in the pre-singularity time period and follows a world where it's a world on the verge of a singularity and explores what it will live like, what it will be like to live as sort of events get stranger and stranger and more artificial intelligence piles up in our world, sort of on the verge of an intelligence explosion. So those would be my top three favorite fiction books. And I think I'll probably limit my reading list just to the fiction because I think it's so important that people in general be inspired and not just guided. And I think really good works of science fiction, contrary to the statements by some that great science fiction has to sort of have intrinsic literary value or somehow reflect on the state of the human condition. I think bogus way to view science fiction. I think the best science fiction illuminates paths ahead of us in a useful way and enables us to do a better job of planning for the future. And I think those three books do an outstanding job of that.
Beautiful. With that, thank you so much, Alex. I think that's fascinating. As a last question, we definitely I would love to have your closing perspective for our listeners and viewers. If they want to take away, what would you advise and suggest these guys?
I would say don't underestimate the power of technology. Don't underestimate the power of artificial intelligence. And these advances are coming very, very quickly. So takeaway message would be understand AI is set to become totally ubiquitous. Ignore it at your own peril, and think about ways that you would want the future to play out where everyone has the same values that they do right now, but everyone is 100 or 1,000 times more intelligent, whatever that means, and start building towards that future, because it's coming up shortly.
Interesting. With that, thank you so much, Alexa, for being really candid with your time, walking our community about understanding what AI is and how it's shaping up to be. Love to have you back on our podcast. You're always welcome. Thank you so much with your journey. Good luck, and again, wish you nothing but success in your AI journey.
Thank you very much. Thank you for having me.
I thought I was sick of home, but actually I was homesick. Never really knew that I would have to grow up so quick. I'm so uncomfortable, don't know anybody here. Just a couple dudes that I met once, that's it. And I go into the booth feeling nervous. Got butterflies in my stomach like I'm so worthless. Is the mic on? I don't know how to work this. Inside I'm breaking down, I hope I'm not up on a